In this lesson, we will study about one very important statement which is used to repeat a statement or a block of statement multiple times. I will illustrate the idea with a scenario which is usually taken as a joke on the teachers that they give a penalty to their students to write down something multiple times when student does some kind of a mistake. For example, if a student is submitting the homework late, then I being a teacher can give him a penalty to write down 100 times that I will submit the homework in time. If I give him the penalty like write down I will submit homework in time, I will submit homework in time, and again I will submit homework in times, and if I write that things 100 times myself, it's like giving penalty to myself. So what I should obviously do is this statement that write down I will submit homework in time for 100 times. Now this indicates to the student that he has to write the statement 400 times. This 400 times specifies how many times he has to write this statement. Similarly, in programming, if I have to print this statement that I will submit homework in time, and if I have to print it 100 times, I can copy paste this print statement 100 times, but that's a foolish idea. So for such cases, we have a statement known as for loop, like we have this for here, which specifies how many times we have to do the job. Why we call it as a loop will be cleared after some time. Some of you might be thinking that we can use a static operator in the print statement, and that is going to print the same statement 100 times. I can put the new line escape sequence over there so that every print statement is printed on a new line. And yes, we have the statement printed 100 times. So we did this without the for loop. So let me change the penalty that we have to write the statement with numbering. Like this. Now you have to print an increasing number with the statement, and now you cannot do this using the static operator within the print statement. And that is something we can do with the for loop. Some of you might be thinking that the last topic we studied, which was user-defined functions, and we said that we create user-defined functions when we have to repeat a logic multiple times. So is that same what we are discussing over here, that we want to repeat something multiple times? There is a huge difference between the two scenarios. In case of user-defined functions, we create a function, then we have to call the function whenever we want to use that. So if I have a user-defined function, for example, finding the area of a triangle, and if I have to execute that function 100 times, I will have to call that 100 times. On the other hand, in case of for loop, we actually specify that repeat this thing for this many times. Now let's first see how we can solve this problem in hand using the for loop. You will not understand the syntax right now, but let me first complete this task and show you the output. So you can see that we have the statement printed on the output and having those increasing numbers. So now let's discuss the syntax of this for loop in detail. First, I will talk about this function range, to which I have provided 100 as the input argument. You can easily guess that this 100 is over there because I want to repeat something 100 times. Basically, this range function generates some values which are 100 for this case, and that controls the number of repetitions. So if I use the function range and pass in the value as 10, it is going to generate 10 different numbers. Let's try to print that. It is printed something like this, and it's not clear what it means. I can convert the output of range function to a list, which is one data type in Python. We haven't studied about the list yet, and we don't need to know about that for the for loop, but I just want to show you the numbers which are generated by the range function. So let's see the output now. And you can see that these are 10 numbers because we specified 10 as the input argument of the range function, and the numbers are from 0 to 9. So this range function generates integers starting from 0, and the last will be the input argument minus 1, so that the total integers generated by the range function are equal to the input argument of that function. So if it is range 100, the integers will be from 0 to 99. The starting integer is 0, but we can also specify that by ourselves. So now we have two input arguments of this range function. The first integer indicates the start of those numbers and the second integer indicates the end of those numbers, but that end is not included in those numbers, meaning that the last number will be that number minus 1. So we have same numbers generated again. Now if I specify 3 as first input argument instead of 0, it means that the integers which will be generated will start from 3 and they will end at 9. I can specify negative integers as well. For example, this minus 2 means the integers generated will start from minus 2, then minus 1, then 0, 1, 2 and till 9. So that's how we can specify two input arguments of this range function. The first indicates the start of those numbers and second indicates the end without including that. They are called as start integer and stop integers of the range function. There can be a third input argument of this range function as well. That will indicate the step size of those numbers being generated. Default value of step size is 1. So if the starting value is 0, the next value is 1, then the next value is 2 and then the next value is 3 and so on. So the next value is generated with the step of 1. So if I specify that step as 2 over here, it means that numbers will start from 0, but the next number will be 2, the next will be 4, and so on until the numbers are less than 10. You can see that on the output. There is also a possibility of negative step size. Now here the start value 20 is bigger than the stop value which is 10, but the step size is minus 2. So the first integers that will be generated will be 20, the next will be 18 because of the step size of minus 2, and then will be the 16 and so on until this process does not cross 10. So previously when I said that the second input argument, which is known as the stop integer, specifies the ending integer and it is 1 less than that number, that is true only when we are not specifying the step size, which means the step size is positive 1. But if we have a different step size, either positive or negative, then it is not 1 less than that number, but it will be the sequence of those numbers generated before they cross that stop integer. Now if I have this kind of a case where I'm saying that the numbers will be starting with 20 with a step size of 2 and they should reach till 10, but it is not possible because for positive step size, start integer cannot be greater than the stop integer. So in this case you can see we have an empty list, which means no number is generated. So that's how we can use the range function to generate different integers. If we have a very simple case that we have to repeat something for certain number of times, then it's very simple to use the range function that we will just specify that number of times in the range function, for example 50 times, but in some other cases we might need to use the step integer as well. So this range function is clear, so let's see the other detail of this for loop syntax. I will remove this numbering sequence for the simplicity. So a for loop starts with the keyword for and then we specify a variable known as the loop variable. This I is just the name of that loop variable. It can be anything. Usually we specify the loop variable as I, j or k, but it can be any variable name. Then we have this keyword in and it should be used as it is, and then this range function where we specify the number of times we want to execute the for loop. So essentially what I in range 100 means that I will get the values of those integers generated by the range function one by one, and then for each of those values it will execute the block of that for loop. The block is specified by placing a colon at the end of for loop statement, and then the block starts with an indentation as on line number 3, which is very similar to the one which we have seen in cases of if-else statement or in case of user-defined functions. Let's just write one statement before this for loop. The block of for loop can have as many statements as we want, so I'm just writing one more print statement inside that. And now you can see I haven't placed the indentation on line number 5, which means that the line number 5 is not the part of the block of the for loop. I will show you the execution of this program step by step, and I think instead of 100, let's put some smaller value, for example 5. I am placing the breakpoint on line number 1. So now interpreter is on line number 1. Line number 1 is executed and now it is on line number 2, which is the for loop. So as I said earlier, that variable I will get the values generated by the range function. So keep an eye on the variable window, and when I press the step into button, you can see the variable I is defined on the variable window and the value is 0 because that is the first value generated by the range function. Now we are inside the for loop block. It will execute line number 3. Now it will execute line number 4, which is the last line of the for loop block, and see carefully that now interpreter has moved back to line number 2, which was the for loop, and that's why we call it as a loop. Now when I will press step into button, you can see the value of I is changed to 1, which is the second integer generated by the range function. Again the block of the for loop will get executed and it will loop back to the for loop statement. I will get the next value, the block will get executed, it will loop back again, I will get the next value, and so on. And now interpreter is at the end of the block of the for loop and I is having the value 4, which is the last value generated by the range function. So see carefully what happens now. It will loop back to for loop statement, but now interpreter will see that I is already having the last value of the range function and it cannot go beyond that. So now when I press step into button, it will not enter into the block of the for loop, and you can see that it has moved to line number 5. So that's how a for loop works. So this for loop block was executed 5 times, and one complete execution of the for loop block is known as iteration or iteration, whatever you want to call. I will pronounce it as iteration, so we can say that there were 5 iterations of the for loop. In each iteration, the loop variable I had different value, starting with 0 on the first iteration to a value 4 on the 5th iteration. And we can use the loop variable, for example I in this case, inside the for loop block. For example, if I have to print the numbers as we started with, I can specify that as I plus 1. So I will be 0 in first iteration, this I plus 1 will be 1. I will be 1 in second iteration, so that 1 plus 1 will be 2. And so on. When I will be 4 in the last iteration, that I plus 1 will become 5. Now let's see a few tasks which we will be doing using the for loop. The first task says that take a positive integer from user and display the square root of it. Of course, we will be assuming that user will be entering a positive integer every time. And the task says that we have to do this 10 times. So let's first write the simple program that will take a number from the user and it will display the square root of that number. Now if I have to do this 10 times, it means that these are the two statements which I want to execute 10 times. So what I should do is that I will make these two statements as the block of a for loop which should have 10 iterations. I will add one indentation to make these two statements as the block of the for loop, and we are done. You can see the program will keep asking me to enter a positive integer and it will stop after the 10 executions. You can see the step-by-step execution by yourself. Now let's see another task. It says that take a positive integer from the user, of course with the assumption that user will be entering a positive integer, and then display the square root of all integers starting from 1 till the entered integer. So if user enters 10, I have to display the square root of all integers from 1 till 10. I will change this program as per new requirements. Previously we had to take the input from the user 10 times, so this input statement on line number 3 was the part of the for loop block. But for this task I have to take the input only once, so I should move this statement outside the for loop. So now the integer entered by the user will be stored in variable num. So if it is 5, I have to display the square roots from 1 to 5. If it is 20, I have to display the square root from 1 to 20. So it means I need a for loop which will start from 1 and it should end at the value of this num variable. So here I can specify this thing inside the range function that the starting value is 1 and the stop integer is num plus 1, because we know that the last value is 1 less than the stop value. Now if I run the code, let's enter 4 as the input and we can see 2 being displayed 4 times. It is a square root of 4 being displayed 4 times, but we were interested to display the square root starting from 1 till 4. The problem is on this input argument of square root function. We have specified it as num, which is fixed to 4 for that case. So that means it will display the square root of 4 always. So here I should use the loop variable. I know it is the loop variable I which will be getting the value starting from 1 till the num. So instead of num, I should use the loop variable I over here. And now you can see when I entered 4, it has displayed the square root of 1, then 2, then 3 and then 4. Remember, this I is just the variable name. I can have some different name, for example n. Let's run the code one more time, and this time I am entering the value as 10. And these are all the square roots starting from 1 till 10. Now here is another task. It says to take a positive integer from the user and then display the square root of all integers but starting from the entered number and going down till 1. So it is very similar to the previous task. The only difference is that now I have to display the square roots in reverse order starting from the entered integer till 1. So I just need to change the input argument of this range function. I will specify num as the start value, then 0 as the stop value so that it will actually stop at 1 and the step size will be -1. And now you can see the square roots in the reverse order. So please go through the lab manual. And then we have few tasks to understand the basic working of for loop. So this task 1 says to take a positive integer from the user, suppose in variable a, and then display the static box of size a by 10, which means that there will be a number of rows and the columns are fixed to 10. Then there is discussion on the indentation, which I hope should be very much clear. Then task 2 says to take a positive integer from the user again and then display the integers 1 to the entered number and the cubes of those numbers separated by a tab. Then task number 3 is about displaying the multiplication table of 12 and can you identify if you need a for loop over here or not. See carefully that this thing is fixed in all print statements and these are the values which are starting from 1 till 10. And this indicates that we can have a for loop and we can generate those numbers from 1 till 10. Then we have equal sign in every line. And then we have these numbers which are basically the products of these numbers which we will be generating using the range function with 12. So let's see how we can do this. As we know we have to generate those numbers from 1 till 10. So I will specify that using the range function and will specify first input argument as 1 and the second input argument as 11. So now I will be from 1 till 10 starting with 1 on the first iteration and the 10 on the 10th iteration. So what I need to print? I have 12 times in each of the line, so it will be fixed to 12 times. But then I have 1 in the first line, 2 in the second line and so on, so I should use the loop variable I over here. Then is the equal sign which is fixed in every line, and finally for the right side of that equal sign, we should have product of 12 with I. And you can see the multiplication table displayed as we want. Now in next task, instead of multiplication table of 12, you will take that value from the user. And secondly, instead of displaying the table till 10, you will take that value of the final limit from the user as well. For example, if user enters 5 as a multiplication table and 12 as the limit, it means that you have to display the multiplication table of 5, but you will not stop at 5 times 10 equal to 50. You should go till 5 times 12 equal to 60. Then we have a couple of tasks related to displaying different triangle shapes and the height of that triangle being specified by the user. The purpose of these tasks is not to display a triangle shape, but to understand the execution of the for loop and most importantly how you can use the loop variable inside the block of that for loop. There are a variety of things we will be doing with the for loops in future. Now the last thing I will discuss in this lesson is that we can have a for loop inside a user-defined function. Actually the different statements that we are studying in this course, they are independent of each other. As we studied if-else statement and we saw that inside a user-defined function we can have an if-else statement. Similarly in a for loop block we can have an if-else statement, or maybe inside a user-defined function we can have a for loop. So depending upon our requirements, we could have these things. So here is a code which simply displays the box of static. I will copy this code And you can see that it is taking the input x and y from the user as number of rows and the number of columns, and then this print statement is printing the static y times, meaning that there will be y statics printed, which we can say are the columns of that particular box, and we have to display these y static how many times? As many times as we want the rows of those, and that is specified in variable x. So I should use that in the range function of the for loop. So you can see a 5x3 box of a static is displayed. Now I want to create a user-defined function for this. The name can be something like drawbox, and I will specify two input arguments as the rows and the columns by any name, for example m and n. Then the same for loop to display the static box. And now outside the function in the main program, I can actually call that function. I will specify the input arguments as entered by the user in variable x and y. And you can see that working. Then there is this task 8 in the lab manual. It is similar to task number 4, but you have to do that using the user-defined function. You will create a user-defined function display table. It will have two input arguments, one for the multiplication table and second for the final limit of that multiplication table. So that's all from this lesson. We will cover the remaining part of lab manual in next video. Thanks for watching.